Hi everyone, I am Ashwini K S. I am currently pursuing my Bachelor's of Engineering in Kalpataru Institute of Technology in third year in the domain Electronics and Communication Engineering.
Everyone, my name is Sushma, currently pursuing my engineering in information science from Kalpataru Institute of Technology, TIPTO. Me and my teammate are going to present a project on home automation using Arduino and Blynk IoT. I would like to start this presentation by our learnings. We started our journey by learning C programming fundamentals such as data types, operators, conditional constructors, loops, arrays, etc. As I mentioned in this slide, moving ahead, we had learned embedded systems. Embedded system is nothing but a combination of software and an hardware which intended to do a specific task. There are three main components in embedded system: software, firmware, and an hardware. Unlike other computers, embedded system performs few specific limited tasks. Embedded systems have peripherals such as serial communication interfaces, synchronous serial communication interfaces, universal serial bus, and many more. Classification of embedded system. We mentioned three main important classifications among embedded systems. There are real-time embedded system. These are strictly time specific, which means this embedded system provides output in particular defined time interval. This type of embedded systems provide quick response in critical situation, which goes most priority to time based task performance and generation of output. That's why real time embedded systems are used in defense sector, medical, and healthcare sectors. The main example for this is traffic control system. We mentioned three main embedded systems here: standalone, mobile embedded system, and networked embedded system. Standalone means independent of host. Mobile embedded systems are portable and movable. Network embedded system connected to network, which may be wired or wireless to provide output to the attached device. Many examples for this are micro oven for standalone embedded system, smartwatches for mobile embedded system, and home security systems for network embedded system. Moving further, we also learned microprocessor and microcontroller. Microprocessor, a bare processing unit with input, output, RAM, ROM, and other peripherals connected externally. Microcontroller processor unit, input, output, RAM, ROM, timers, etc. integrated on a single IC. Including to this, we also learned system on chip, where multiple microcontroller and microprocessor integrated on a single IC along with additional features like digital signal processing unit, radio signal processing unit, Wi-Fi modules. We also go through the topic of memory. There are three types of memory: RAM, ROM, hybrid memory. Volatile RAM memory is volatile, requires power supply to retain data, can be written over multiple times. There are two types of RAM memory: static RAM and dynamic RAM. When it comes to ROM, non-volatile, data not erased on power shutdown, can be not changed once it is written. Types of ROM are one-time programmable, the EPROM, and masked ROM. Next, hybrid memory, non-volatile but be changed or overwritten or a particular number of times. There are two types of hybrid memory: double EPROM and flash. This is the block diagram of embedded system, where we have used sensors, analog to digital conversion, CPU, and digital to analog conversion, and actuators, software and memory. This is the complete block diagram of embedded system. Coming on to most important part of this project is Internet of Things. So what is Internet of Things? It's the network of physical objects that contain embedded technology to communicate and sense or interact with other internal states of external environment. This devices ranges from ordinary household objects to sophisticated industrial tools with more than 7 billion connected IoT devices today. Experts are expecting this number to grow 10 million by 2022 and 22 billion by 2025. By means of low cost, the cloud, big data analytic and mobile technologies, physical things can be shared and collect data with minimal human interaction in the hyper connected world. Digital system can record, monitor and adjust each interaction between connected devices. The physical world meets the digital world and they cooperate. This is the architect of IoT, where we it includes device connectivity, device processing, and analytics presentation. In device connectivity, we had used devices IoT client gateway, cloud gateway, IoT solution backend, business connectivity. Here is a little representation of architecture. Note, I would like to hand over the presentation to my friend Ashwini. Thank you.
So now I'm going to explain about the project requirement, what are the tools we have used and demo of the project. Our project is home automation. In this, we have controlled the garden lights on the basis of sunlight intensity. In that, if sunlight is more, garden light brightness must be decreased. If the sunlight intensity is less, garden light should be having the more brightness. And we will control the temperature system, heater and cooler through mobile Blynk IoT hub. We will also monitor the water tank through this automation. Now, project solution. So we have used some sensors, controllers and software applications to develop the project. We have used LDR sensor, which is nothing but brightness detector, and LM35 sensor. It will detect the temperature. We have used water tank to show how to fill the water through serial communication protocol. Specifically, we have used the Arduino controller in that at Mega 328p. To code, we have utilized the software Arduino IDE. Through mobile application which is Blynk IoT, we remotely control the above requirement. To do the simulation, we have used Picsimlab, null simulator for serial communication. I am going to explain about what is LDR. LDR is nothing but light dependent resistor. It is used to detect the sunlight brightness and send the analog signal to microcontroller. Then the microcontroller will adjust the brightness of the garden light with respect to analog signals sent. Doing this function, ADC operation will take place, which is nothing but analog to digital conversion. It will read the analog input and convert it into digital output through three steps. First one is sampling. Sampling is nothing but breaking continuous signals into discrete signal. Second one is quantization. And third one is encoding, that is, assign digital value to each signal level. This is the calculation has been done to control the brightness of the lights through resistance present in the LDR. PWM. PWM is pulse width modulation technique. PWM is used to simulate analog output. It works on persistence of vision. If LED is switched on or off in quick succession, brightness can be controlled by controlling the amount of time in the LED in one cycle of output signal. It is used to control the brightness of the LED. I am not going to explain much about this here. I will explain all in the demo session of the project. Now, temperature system. LM35 sensor will sense the temperature of the room. This temperature is displayed on the CLCD and through the Blynk IoT mobile app. We will control the heater cooler. To do this, we have created so many data streams in Blynk dashboard templates. These act like virtual pins for exchange of data between mobile app and microcontroller. Water tank. We will monitor the water tank through serial communication. This is the serial port connection made between Arduino controller and serial tank. This is the snapshot of overall working of the project. And this is the snapshot of mobile Blynk IoT app. And you can see the widgets created for our project. So now I'm going to give the demo of our project. So see here in the CLCD, it's already showing the temperature and volume of the tank. The LED is also turned on. Now in the LDR, I will slowly increase and decrease the resistance. See, the LED brightness also changes according to the resistance. Now I am going to mirror my mobile Blynk IoT app here to control the heater and cooler. See, now I will turn on the heater pin. The temperature also automatically increasing now. Now it is 34 to 35. If I turn on the cooler, the temperature will automatically decreasing. See, now I will turn on the cooler pin. See, now the temperature is drastically decreasing. You can see that in the CLCD. And the fan also turned on. See, now the temperature is 27 from 34 to 27. Now I will show the cereal tank. See, now the tank is full, 3000 liters. So in the notification bar, so see, in the notification bar, it is showing that the water tank is full. Now I am going to turn on the outlet valve to make the tank empty. See, now the tank is having the volume 2330. It is decreasing, volume is decreasing. If I turn on the inlet valve, the tank starts filling. This is how our project will work. Thank you, Amatex, for giving a beautiful opportunity in this internship. We learned a lot and we developed a project called Home Automation. It is such a great experience for us. Thank you once again.